Assalamualaikum warahmatullahi wabarakatuh. My name is Zakwan Shukri bin Muhammad Shah. My matric number is DE190045 and my supervisor is Prof. Madia, IRTS Dr. Muhammad Rozali bin Haji Muhammad, and to my panels, Dr. Chu Chang Chun and Dr. Nur Surayani binti Suryani. So today I will be presenting my final year project, which is real-time pothole detection using deep learning. So for introduction, this project is mainly to detecting pothole using deep learning approach. So pothole will form from environment condition such as flood, natural disaster, and also the use of low quality material for to form the road. So this issue can lead to accident, vehicle damage, and also increases the vehicle maintenance cost. So with the technology advancement, this proposed project using convolutional neural network, which is CNN, to recognize pattern of pothole in video and also in images. So the proposed system takes video data, which is from a camera that mounted on a vehicle like a dash cam, but with a layer of detection from the image dataset, and also that will detect pothole in real time. So my problem statement is pothole can pose a significant threat to driver safety because they can also cause vehicle damage, and identifying potholes on roads with traditional technique may be costly and also consume more time for road maintenance teams. So to implement a deep learning model detection that can accurately identify potholes in real time using video or image data from road or vehicle cameras. So my objective is to implement a deep learning model using convolutional neural network of YOLO version 5, which is you only look once version 5 algorithm that can accurately detect potholes in image and videos. So secondly is to apply the real-time pothole detection using the implemented deep learning model that we have been trained with the image dataset. Third, to analyze the result based on the deep learning method from the implemented trained model using the criteria of the accuracy, which is the F1 score, the precision, and also recall. So in the scope of work, the dataset preparation will be generated from the label image software tool, which is the software that I've been using to create the bounding boxes and save the annotated file in YAML files, which is written in Python language. The purpose is to self-label our own images for object detection. We can create so many classes, which is the object that we want to detect later in the model detection. So the Jupyter Notebook is one of the platform that used to annotation and augmentation process, and also produce the trained dataset. Deep learning method that will be used in YOLO version 5 is to classify and identify pothole from the label annotated images dataset. So beside the Jupyter Notebook that I've been using, and then the software that used to train from my own laptop is I've been using the Google Collaboratory virtual GPU to produce uh, to train the pre-trained model more fast than than if we want to use only by using CPU. So the hardware used to implement the real-time detection is I've been using the Raspberry Pi 5 Model B. They connected with the display of LCD HDMI 5-inch. So in the methodology, from the start, from the very first, the dataset preparation, including the image annotation, and then the pre-processing image dataset and also the annotation. The next step is to split the dataset into training and validate. So in the stage of split the dataset, we can also set the learning rate of the model itself, the batch size, how many we want to use, 2, 4, 8, 16, 64, the loss function, or we can put the optimizer, and also the number of epoch that we want to use to generate the train model. And then the next step is our model train. We can save the train model. If our model is not trained enough, we need to manipulate the train and validate ratio, and also configure the all the hypermeter. And then once we have saved the train model, the best train model, we can use it to test the images as the testing to train our model. Is it good enough to use in the real time? And then the next step is apply the pothole detector. We can load the pothole detector in the input video stream by using only the webcam or the built-in camera from the Raspberry Pi. So the first step, the dataset preparation and annotation. We can generating and extracting the raw data from the raw images to build the own classes of the pothole. So I've been using 1,200 images to make the train model more effective without using large epoch. If we want to use a large epoch, we only need a few data sets. If we already have a bunch of data set, we did not have to use the large epoch. And then extracting the raw data after build the own classes of potholes, we can arrange it in a single table to use to make it easier. And then the image augmentation to help the model detection that we want to train be more precise. The function of augmentation is same as the annotation, which is it helps in the precision and also the recall to make the data set more precise. So the augmentation have the function which is it can flip-flop the images, it can rotate clockwise, So in the next step, which is the YOLO V5 training. So for the firstly, just downloading the YOLO V5, all the requirement file that we need to use when we want to train the model later. So basically we just download the model detection from the GitHub, and also preparing the annotated file that we already done before. And the next, preparing the train validation and also the test set. The test set that we want to use, just random take it from the train set, implementing the training process, and also executing the inference process using the train model. So for the real-time implementation, to use to implement the real-time implementation in a car, Raspberry Pi is the main device that I use. The camera that I've been using is only a USB webcam, also the car socket to supply the current for Raspberry Pi, mouse, and also the laptop. The laptop that I've been using is to display the Raspberry Pi desktop. So for the result and discussion, this is the outcome of my YOLO version 5 train model. As you can see here, from the far, the pothole have the confidence rate of 0.32. If we get near and closer to the potholes, the pothole will be generated with a confidence rate of 0.57. So for the result and discussion, I've been using 1200 images and the total epoch of only 50. So as we can see here, from the very first epoch, the precision that we get is 0.35468, but in only epoch 9, the precision already 0.67. This suggests that the model is learning and improving its ability to make the prediction as it trains on more data. So the basic definition of the precision is the proportion of data that the model predict to be a pothole that were actually a pothole. The differences with the recall is the recall is the indicator that show the actually pothole that the model correctly classify as a pothole. So for the MAP 0.5 is mean average for the precision for only 50%, and also the last column is mean average for the precision between 50% to 95%. So for the best train model that we get here is on the 40 epoch, which is the precision is at 0.80004. The recall is 0.73025. The mean average precision is 0.75988. The another mean average precision 50 to 95% is 0.4725. So we have come to the F1 confidence curve, which is we only have single classes which we only want to detect a pothole. So the F1 it shows that the F1 score for all classes which is only potholes at a confidence level of 0.432. So in this case the F1 score is 0.76, or it means that 76% accurate at identifying object with a confidence level of 43.2%. So as you can see here, a higher area under the curve indicates better performance of the model. So the F1 score is basically a harmonic mean of accuracy contained both for precision and recall. So for the precision and recall, the precision is an indicator of the true positive to all the instances of positive prediction, which is we need to combine both two element to get a precision. So for the recall is the indicator of true positive and from all the actual positive instances. So to get the absolute recall, we need to combine those two elements. So precision is a measure of when your model predict how often does it predict correctly. So a recall is a measure of has your predicted every time that it should have predicted. So here for the pothole classes, it gets a precision of 0.76 at mean average precision of 50%. So in the precision confidence curve, for all classes, the precision hit 100% of 100% value of precision with the confidence of 0.904. So for the recall and confidence, the potholes classes for the recall is 0.87 at 000, and lastly it hits around 0.9 confidence value for the recall 000. So we have come to the conclusion and recommendation. So this project is successfully run and can detect the pothole with only use limited CPU performance of Raspberry Pi 5 Model B with maximum of 3 FPS only. So the recommendation that we want to use if we still want to use on a embedded device such as Raspberry Pi, we need to have an accelerator to boost the performance of our device so that we can run the pothole detector more effectively with numerous number of FPS while we run it in real time. So That's all for me. Thank you. Hi everyone, this is my real-time pothole detection setup in a car. The Raspberry Pi is connected with the LCD screen by using HDMI cable and GPIO port. Car power socket is used to supply maximum 3.6 amp by using USB-C cable to run the Raspberry Pi.